Well, hello to all my grade 9 students who are taking academic math. We're going to look at analytic geometry. This is the extra unit that is in the grade 9 academic program that is not in the grade 9 applied program. I wish you luck, and I know we can make this transition. Our learning goals for this section of the course are threefold. First, we're going to be able to determine the slope of a line. But we know slope right now as rate of change. So we've done that, and we're going to continue to do that. We're going to call it slope now. We also need to be able to determine the equation of a line. In the past, when we were doing equations, we came up with equations that look like this. And when we were doing tiles, we came up with the number of tiles is equal to how much it grows by for every position plus what we started with. So we've seen equations like this before. We called this value the rate of change, and we called this value the initial value. So the rate of change was how much it grows by. Do you remember that? And the initial value is what it starts at. Well, things haven't really changed much because here's the n in this equation, and the x in this equation is another variable. The m is the slope, or rate of change. And the b, we call it the y-intercept, or the initial value. So we're just using different words for the same thing. So y equals the rate of change, how much I grow by, so this is still the growing piece, times the variable, plus the starting value, or the y-intercept. So it's the equation of a line. The third thing we're going to be looking at is applying properties of parallel and perpendicular lines. The equation of a line is y equals mx plus b. You can see it in my corner here, and you can see it here. M is the slope, also known as the rate of change, which we've been done before. And the b is the y-intercept, but also known as the initial value that we've done before.
On this page, we'll need to identify the slope and y-intercept for the equations. I'll do a couple with you, and then you can do the others after. So if you look at the top equation here, y equals mx plus b, remember that m is the slope. It is the part that's growing, so the slope times x plus the y-intercept, so that the y-intercept is where it starts on the y-axis or where it crosses the y-axis. So for the first one, the slope is in front of the x, so it's 1/2. And the y-intercept is the number that's on its own, so -1. In number 3, the slope, again, is in front of the x term, so -2/3. And the y-intercept is a number on its own, -2. You can pause the video now and think about the other ones. Let's try a couple on this page just to be sure we know what we're doing. Again, we're identifying the slope and the y-intercept, and the general equation is y equals mx plus b, where m is the slope and b is the y-intercept. So in the first one, m is in front of the x, so 4, and b is equal to -3. In the second one, m is in front of the x, so 7, and b is equal to 7 also. Pause the video and think about the other ones. Okay, so previously when we saw a graph, we thought about rate of change and initial value. The slope is really just what we know as the rate of change. So when we're finding slope in a graph, we're going to find it the same way we found the rate of change, because they're the same concepts. So we need to choose 2 points. And remember to choose 2 points where they go like kind of exactly through. So I kind of like this one at the 10 there. And then I kind of like this one here too. So I'm going to draw a rise and a run in order to determine the slope. So my rise, I went from, this is 2, up to 10. So my rise is 8. And then on the run, I went from 1 over to 3. So my run is 2. In order to determine my slope, it's rise over run, so 8 over 2, and if I simplify that, that's 4. So the slope for this graph is 4. Let's do a couple on this page. So I'm going to use the points that they've already given us to draw the rise and the run. So my rise for this one, for number 1, is 3. And my run, it's going from -5 to 5, so that's 10. So my slope then is 3 over 10. Notice that I have the formula in the middle of the page, slope equals rise over run. I'll do one more on this page, and I'll do number 4. And the reason I'm going to do number 4 is it's slightly different. This slope was going up, so this is positive slope. This one's going down, so it'll be a negative slope. So we need to make sure that our number is negative. I generally include the negative as part of the rise, so knowing that it has gone down. So it went from 5 at the top to -5 at the bottom. So it traveled 10, or -10 because it went down. And then I went from -5 on the x-axis to 4 on the x-axis. So my run is 9. So my slope then would be -10 over 9. I only include the negative with the rise, and also I just double check that if I get a negative number for my slope, that my line is indeed going down. I hope all is well at home. Stay healthy, helpful, and calm. And contact me any day at 11 or 12:30, any weekday. Thank you. Bye.